Hello there, it's me, Statistics Salazar Slytherin, and I'm here talking to you about box and whisker plots. Now here's a question. Why was Mad-Eye Moody such a bad teacher? 'Cause he couldn't control his pupils! Ah!
First thing we're talking about is a maximum. That's the greatest value or quantity. So if we have a data set right here and we want to figure out the maximum, it's probably the easiest thing to do to reorder this from least to greatest. So if we were to reorder this from least to greatest, we would get something that looks like this. Now that it's reordered from least to greatest, we can see what our maximum is. The greatest value would be 10. Now the minimum would be the least quantity or value possible. So here, that would be 4. And again, it helps greatly that we reorder it from least to greatest. It allows us to easily see what our max and min are. Now, a box and whisker plot, also called a box plot, is a graphical representation of statistical data based on the minimum, first quartile, median, third quartile, and maximum. And here you can see what these look like. Box and whisker plots. They have a box in the middle with our median, our first quartile, and our third quartile. Then our minimum and maximum are the whiskers. They make up the whiskers of your box and whisker plot. A quartile is any of the 3 values that divide a set of numbers into 4 groups, with each group containing a fourth of the set. So from our minimum to our first quartile is going to be 25% of our data. Then from our first quartile to our median is going to be another 25% of our data. Then from our median to our third quartile is another 25% of our data. And lastly, from our third quartile to our maximum is going to be another 25% of our data. Now the interquartile range, or IQR, is obtained by finding the difference between the first and third quartiles. So if you know what your third quartile is and you know what your first quartile is, all you have to do is subtract those 2 values, and that gives you your interquartile range, the length of that box, basically. An outlier is going to be a piece of data that is numerically distant from the rest of the data. So on your box and whisker plot, those will be denoted by little points outside of your whisker. So just beyond your whisker, any of those points would be considered outliers. If you have a set of data, it's just something that doesn't belong. It's too far outside of your data. So here you can see everything we have is greater than or equal to 275, besides this 5, which looks like it doesn't belong. Therefore, it's an outlier.
How do Death Eaters enter a building? They slither in! Ha ha ha! Example time.
So example 1 says determine the minimum and maximum values of the set of data represented in the graph below. So here we have our box and whisker plot. The minimum is going to be your lowest value, so the farthest end of your whisker on the left. So here, that would be this point right here, which looks like it's somewhere between 15 and 20, so let's call it 18. On this side, your maximum is going to be the farthest point on the right whisker. So that would be this point right here, which looks like it's at 100. So your maximum is going to be at 100. Part B says determine the first, second, and third quartiles of the set of data represented in the graph below. Then find the interquartile range. So first quartile would be this part of the box right here, the left part of the box. So that is your first quartile. It looks like it's just about at 50, a little bit above 50, so we'll call it 51. So your first quartile is approximately 51. Then your second quartile is going to be whatever line is in the middle of your box and whisker plot. So in the middle of the box, you have this line. That is going to be your second quartile or your median. So because it's almost at 70, but a little bit this way, so we'll call it 68 approximately. So again, the second quartile, aka your median. Then your third quartile is going to be the right part of the box. So that would be this right edge of the box is your third quartile. That's between 85 and 90. It's a little bit closer to 85 than it is to 90. So we'll call it approximately 86. That's your third quartile. Then to find the interquartile range, all you have to do is subtract these 2 values. You take the third quartile, subtract the first quartile, and you get your interquartile range, which is about 35. Part C says what percent of the data falls between 86 and 100? What percent falls between 51 and 100? So we'll answer this one first. What percent of the data falls between 86 and 100? So 86 is about right here, and 100? Oh, okay. So it's asking what percent of the data falls between the third quartile and your maximum. Well, that's going to be 25% of the data. That's the whole point of quartiles. This quartile from here, our minimum to our first quartile, that's 25%. Then from first quartile to median, another 25. Then from median to third quartile, 25. And then from third quartile to maximum, another 25. So that would be 25% of your data right there. Then it asks what percent falls between 51 and 100. So 51 and 100 would be from your first quartile to your maximum. So that would be 25%, 25%, 25%. So that would be 75% if we were to add those up. So that's what percent of the data falls between 51 and 100.
Why can't Voldemort wear glasses? Who knows? Ha ha! You try.
Okay, so answering the same questions. Part A, we want our minimum and maximum. So minimum, your leftmost point on your left whisker. So that would be this 2 right here. That's going to be your minimum. Your maximum is going to be your rightmost point on your right whisker, which would be this 16. That's your maximum. Now part B, your first quartile is going to be the left part of this box right here, which is going to be 5. Your second quartile, aka your median, is going to be the line in the middle of your box. So that's going to be this 9 right here. The third quartile is going to be your right line or your right part of the box, which is going to be this 13. And then to figure out your inner quartile range, or IQR, you just take the third quartile and subtract the first quartile. So 13 minus 5 is going to give you 8. That's your IQR, or interquartile range. Now part C says what percent of the data falls between 5 and 13. So 5 is going to be your first quartile, 13 is your third quartile. And again, quartiles represent 25% of your data. So between the first and third quartile, right, this would be 25% of your data between quartile 1 and quartile 2. And then between quartile 2 and 3, that's another 25% of your data. So if we were to add those together, that's 50% of your data right there. Now example 2 says graph the max and min from the given set of data. So we are given a set of data, it's out of order. Anytime you're given a set of data that's out of order, you need to reorder it from least to greatest. So here we're going to reorder that from least to greatest, and now we don't need this one anymore. Cool. Now that we have this, we can figure out what our max and min are. Our minimum is going to be this 1 right here. So above 1, we put a little point. That's our minimum. Our maximum is 7. Above 7, we put a little point. That's our maximum. Sweet. Next, graph the second quartile, aka the median from the given set of data. So the median is the middle point. Since we have an odd number of data points, we will have a median. We don't have to add 2 numbers together, divide by 2. We have 3 and then 3. So this middle one, 2, is going to be our median. So at 2, we put a little line. That's our median. Oh, this is going to be a little skew. Cool. Next, what we do is we figure out our first and third quartiles. So here's how you figure that out. We just need to figure out the middle number from the first half of the data and the middle number from the second half of the data. Now, if there is a median, like there is here, we ignore that. Okay, so the first half of the data we just take as these 3 points right here. And the second half we'll take as these 3 points. So the middle of this first half of the data, we just take this 1.5, right? That's the middle of these 3 points. So we take that value, that's gonna be our first quartile. Then these last 3, what's the middle of that? That would be 6.2. That's your third quartile. So at 1.5, we're gonna draw a line, and that's going to be our first quartile. At 6.2, we're going to draw a line, and that's going to be our third quartile. We then draw lines connecting the minimum to the first quartile and the maximum to the third quartile. So draw a line connecting the minimum to the first quartile, like that, and the maximum to the third quartile, like that. Then we draw a line connecting the top and bottom of the first and third quartiles. So top of the first quartile to the third quartile, bottom of the first quartile to the third quartile. And look at that, we have successfully created a box and whisker plot. Boom, done. Now example 3 says create a box and whisker plot for the given set of data. So here we have a set of data that is out of order. So we need to reorder it from least to greatest every time. And when we do that, it looks like this. Now we don't need that original set anymore. From here, we go ahead and pick out our minimum. What's our minimum? That would be 1. So at 1, we go ahead and put a little point. Our maximum is going to be 20. We go ahead and put a point at 20. That's going to be our maximum. Sweet. Next, our median is going to be the middle point of our set of data. So we have 8 data points. Oh, because that's even, we're not going to have a middle number. So our median has to be between 4 and 9. Those are our 2 middle numbers. So how do we figure out our median? We just add those together and divide by 2. So what's 9 plus 4? 13 divided by 2, 6.5. So at 6.5, we're going to draw a little vertical line. That's our median, aka our second quartile. Our first quartile, we look at the first half of the data. So that would be from 1 to 4. So from 1 to 4, we need the middle number. Well, there is no middle number. We have 2 and 3. Those 2 data points are in the middle. So we take those 2, add them up, and divide by 2. Same thing over here to get our third quartile. Between 9 and 20, our 2 middle points would be 11 and 18. So each of these, we add together, divide by 2. Add together, divide by 2. And we draw vertical lines at their positions on this number line. Then all we have to do to finish this off is draw a line connecting our minimum to our first quartile, our maximum to our third quartile, and connect the tops and bottoms of our first and third quartile. And that's how you create a box and whisker plot.
What did Harry ask his godfather when he was angry? Why so serious? Ha ha, you try.
Okay, doing the same thing. So first thing we want to do with a set of data that's out of order is reorder it from least to greatest. Boom, done. Next, we get rid of that old set of data, and from here, we can plot our minimum, which is 3. So at 3, we put a little point. Our maximum, which is 16. We go over there to 16, put a little point. Next, we go ahead and figure out our median. So we have 1, 2, 3, 4, 5, 6, 7 data points, which means we will have a middle number. Our median is 7. So at 7, we put a vertical line. That's our median, aka our second quartile. That's going to be in the box. Next, our first quartile. Now to figure out your first quartile, you look at the first half of the data. Anytime you have a median, we ignore that when we're looking at the first and third quartile. Like here, your median is 7. We ignore that when we're looking at Q1 and Q3. So our first quartile, first half of the data, we're looking at 3, 4, and 6. What's the middle number there? That would be 4. That's your first quartile. Same thing for your third quartile. So we ignore that 7 and 3 data points on the second half of your data, the 8, 8, and 16. What's the middle number there? That would be 8. So that's your third quartile. So we go to 4, we draw a little vertical line above 4, that's your first quartile. We draw a little vertical line above 8, that's your third quartile. So we have determined our max, min, our first and third quartiles, and our median, which is our second quartile. So all we have to do is connect the dots. So our whiskers, we connect the minimum to our first quartile, we connect the maximum to our third quartile. Then our box, we just connect the tops and bottoms of our first and third quartiles, and you have successfully created a box and whisker plot. Now the word problem says the chart below shows the amount of time 100 people in Huntington Beach spend in traffic on a given day. Find the range, the interquartile range, and any outliers for the amount of time spent in traffic on a Monday. Okay, so let's look at this. First, we want to find the range. So it's going to be the max minus the min. So the max here, don't look at these outliers. Those are not your maximums. Your maximum is here. So your max looks like it's about 38, and then your min looks like it's about 12. So we'll go 38 minus 12 is your range. That would be 26. Again, since it's not exact, you don't know exactly what that value is, it's okay if yours differs just a little bit. The interquartile range, Q3 minus Q1. So here, top of your box right here, that's going to be your third quartile. Here, this is going to be your first quartile. So we go, looks like about 29 minus 20. Yeah. So 29 minus 20 gives you 9. So an interquartile range of 9 would be your answer. Then any outliers. Yeah, we said we had 2 up here, right? Those 2 would be outliers. So that's at about, 42 and 46. So those would be your outliers. Perfect.
How do you freshen your breath at Azkaban? With Dementos! Ha ha! You try.
Okay, doing the same thing, but for Friday. So to figure out your range, it's going to be your max minus your min. So it looks like it's going to be about 35 minus 10. So 35 minus 10 gives you 25 as your range. Your interquartile range is Q3, your third quartile minus your first quartile. So that looks like it's going to be about 26 minus 16. And that gives you an interquartile range of about 10. Last but not least, outliers. No, we don't have any points outside our max or our min. Therefore, we have no outliers here.